My dear friends, we all know that as the object is moving, then the concept of velocity or speed is associated with the object which is in motion. So here I am drawing a position time graph. This horizontal axis is a time axis and vertical axis is the position axis. Here position is expressed by x and time is expressed by t in SI unit seconds and position in meters. Let us draw a graph or a curve of a moving object. Okay, a general case. It is a general case in which the object is moving with some velocity or speed, and I have traced a curve in the position time space. It is a position time space. So with varying time, the object occupies different position. This is expressed by this curve. So let us point origin. In this origin, time is 2 seconds and value of position is 0. That means the object is somewhere, it is at rest. So it is 2, 4, 6, 8, 10 like that. And here it is 2.5 is 3, 3.5, 4, 4.5 like that. So this is a time axis and this is a position axis. So there is a large number of points in this curve. So every point in this curve expresses the value of position with respect to time. So if we take the difference between time at this point and the time at this point, we will call it as time interval. That means let us draw a perpendicular to the time axis. So here it is also a perpendicular on the time axis. So let it be t1 and it is t2. Okay, so it is t2. So the difference between the time interval time t2 minus t1 is called time interval. Difference between 2 times t2 minus t1 is called time interval. Okay, time interval. So this time interval, what will be the size of time interval? It depends upon us. Time interval may be large or may be very small. To calculate velocity or speed, we will use this time interval delta t, and in the numerator it will be displacement. velocity is defined as the ratio of displacement by time interval. So what will be the value of displacement? It depends upon the object how much it is displaced. So as time interval is defined as the difference between two different times, similarly displacement is also expressed in this form: x2 minus x1. This x2 and x1 is the position in the curve as x1 and is x2. So at different time intervals, the position of the object are different. At time t1, position of the object is x1, and at t2, the position of the object is x2. So how much the object displaced in time interval delta t? How much is the object displaced in a time interval delta t? That means from time t1 to t2, the object displaced from x1 to x2. So the displacement can be written as delta x is equal to x2 minus x1. So this is the displacement. Displacement is equal to delta x equal x2 minus x1. Now velocity becomes, expression of velocity becomes delta x by delta t, or x2 minus x1 by t2 minus t1. So this is the expression of velocity. So when value of time interval delta t is comparatively large, when time interval is large, then the velocity of the object can be defined as average velocity. Average velocity. When the time interval is large, then velocity of the object is defined as average velocity. But when delta t value is very small, or infinitesimally small, then we called it as limiting value. Limiting value of time, and it is expressed as limit delta t tends to 0. So when time interval is very small, then it is expressed as limit delta t tends to 0. So when we apply this condition to the expression of velocity is limit delta t tends to 0 over delta x delta t, change in displacement by time interval, then this velocity is called as instantaneous velocity. So it becomes instantaneous velocity. So what is the importance of instantaneous velocity? So instantaneous velocity gives us the position of object at different instant of time. That means where the object is at the path at different time is called instantaneous velocity. So we can express velocity in graphical representation also. So this is the initial position of the object x1, and this is the final position of the object, or we can say at time t1 the position of the object is x1, and at time t2 the position of the object is x2. So change in displacement can be obtained by producing this line directly perpendicular over this axis or line, and from here also we can drop a perpendicular over that line. So here we can write x1 and this is x2. So this portion now become delta x, which is change in displacement or change in position. For speed we can say position, for velocity it is displacement. Since velocity is a vector quantity, we have to calculate the displacement value. Displacement is also a vector quantity. And here at time t2, the time interval is what? Difference in time, t2 minus t1. So t2 minus t1 is equal to delta t. Here this value also have same magnitude, it is also delta t. Here the ratio of delta x by delta t is what? Velocity. So this becomes the slope of position time graph. So the slope of position time graph is equal to what? Delta x by delta t, which is equal to velocity or speed. If we are writing here position, then we can say it is speed, and if we write here displacement, then we can say it as velocity. So slope of displacement time graph is velocity, slope of position time graph is speed. So we come to know that the slope of position time graph is what? Speed, and slope of displacement time graph is velocity. So whatever is the nomenclature, but we have to understand that the ratio of change in displacement with respect to time is what? The slope of the curve or graph we have drawn in the space. So average velocity can be calculated by this ratio. And for instantaneous velocity, we have already defined instantaneous velocity as the limiting value of delta t. That means the time interval cannot be very large, but the change in time or difference in time must be very, very small. So when delta t tends to 0, that means very small, the displacement of the object or change in displacement is expressed in terms of a point. Okay, so delta x become a point value. So delta x become a point value in equal interval of time. That means delta x remains same for delta t. That means delta x remains same for same time interval. Then the object is defined as the moving object in uniform motion. So from the slope of displacement time graph or position time graph, for equal interval of time, if the object changes its position in equal value, that means for same time interval the change in position or change in displacement of the object remains same, then the object is said to be in uniform motion. Now we have velocity time graph. Here this is the initial velocity, and after some time the object or particle attains final velocity. This is the initial time interval t1, initial time t1, and this is the after some time interval t2. So from this velocity time graph also we can calculate slope. Okay, slope of velocity time graph gives us what? Change in velocity. What is the change in velocity? We can draw a line here. It is u here. So change in velocity delta v is equal to final velocity minus initial velocity. Final velocity minus initial velocity by final velocity at time t2 minus velocity at time t1. It is t. So velocity at time t2 is v and velocity at time t1 is u. So this is the change in velocity v by time interval t. That means in time interval delta t, the velocity changes by delta v. So this is the slope of velocity time graph, and we know that change in velocity with respect to time gives us acceleration. So acceleration is equal to change in velocity with respect to the given time interval, or we can say that the time required to change or increase or decrease the velocity ratio gives us acceleration.